You are looking at Karnaugh maps. Karnaugh maps are really just funny looking truth tables, but the great thing about them is that you can use them to simplify a logic or a Boolean expression. So I think once you get used to them, you're going to love them even more than you love simplifying Boolean expressions using Boolean algebra, if that's possible. So let's look at these and try to simplify the expressions, and then we'll get into how you create these maps on the next slide. But anyway, this is a two-variable Karnaugh map, A and B. This is a three-variable Karnaugh map, and this is a four-variable Karnaugh map. And you can have Karnaugh maps with even more variables than that, but we probably won't get into them. Anyway, the rules are, let's go back to this two-variable Karnaugh map. I'm back on looking at this one. The rules are you have to circle all of the ones and make the groups as big as possible. Groups are allowed to overlap, and you can wrap around, and we'll talk more about that in a minute, and groups must contain a power of 2. So in other words, you can have a group of 1, a group of 2, a group of 4, a group of 8, a group of 16, and so forth, but they have to be a power of 2. So in this example below, I'm going to circle all the ones. You have to circle all the ones, and this is a group of 2. And then you have to name the group by what they all have in common. So everybody in this group has A in common, right? They don't have B in common because this guy is a not B and this guy's a B. But the name of the group is A. Boom, I have simplified this Boolean expression. It is A. All right, let's go to the next example. Again, you have to circle all of the ones and you make the groups as big as possible. So that is a group of 4, and I have to name it by everything they have in common. And the only thing they have in common is C. They all have C in common. In the next group there, I have these two ones, and I'm also going to make a group of 4 and overlap. Overlapping is allowed, and the name of this group is not A. They have not A in common, and that is it. I am done. Or, oops, that's a plus there, by the way, or not A. All right. So that is it. I am done. Now I know you're thinking perhaps, how come I just didn't make this a separate group of 2? The reason is because I would have to name this not A. They both have not A in common, and not C. That would be a more complicated expression than the bigger group. So you want to make, I'll cross this out. You want to make the groups as big as possible. It means you're going to have a simpler expression. All right, let's go to the next one here. Let's see. I can circle this one with this. Sometimes it's easiest to start with ones that you can only circle with somebody else. So the name of this group is AB, not C. All right. I can do this one with the guy above it. Okay, and the name of that group is A, C, not D. Okay, and I have this one. It looks like I'm going to have to overlap it with that guy. And that group is not A, not B, and C. And I have one more group. Yeah, I'm going to wrap around. Right, that connects with that, and it connects with the guy above it, and it connects with the guy. So all 4 corners wrap around, and now I just have to name that group of 4. What do they all have in common? They all have not B and not D. All right, and there you have it. I have simplified this Boolean expression using Karnaugh maps. All right, hang in there for the next few slides. Now that you've seen Karnaugh maps, let's formalize all of the rules just to make sure you got them. So as you already know, your groups must contain only ones. You're not allowed to circle zeros, right? You're not allowed to circle things diagonally. And you could only group powers of 2. In other words, you can group 1, 2, 4, 8, and so forth. 16, 16, blah, blah, blah. You get the idea. You want to make your groups as big as possible. You have to circle every single one. You're not allowed to have a one not grouped. You're allowed to overlap, as you know. And you want to make the fewest number of groups you possibly can, because that's how you're going to end up with the simplest Boolean expression. And that's it.